I don't know if I can be heard. There is no sound at my end, though.
I don't know. I don't think there's any sound yet until we start.
Welcome, everyone. We've not started. People are still joining. Hello, can you hear me? Can if you can hear me, I would like us to just drop in the comment section. You can hear me. Can you hear me?
Yes.
Okay,
Yeah.
great. I just want to be sure the audio is out. Okay.
Humans have never stopped exploring and surveying the Earth. The human history has witnessed a constantly advancing science and technology. A wider scope of surveying becomes possible, and the accuracy is constantly being improved. The marvelous progress of surveying has been changing the way people understand and create the world. We are Tersis GNSS, committed to improve the life quality of everyone in the world. Our robust products and affordable centimeter precision solutions transform the workflow and make it more efficient. Equipped with in-house designed RTK boards as well as advanced signal processing technology, Tersis GNSS systems provide you the unprecedented flexibility and accuracy in the sky, on the land, in the ocean. Wherever innovative positioning applications are needed, you can rely on Tersis GNSS for continuously accurate and real-time positioning. In Tersis GNSS, every day, we are inspired and motivated to push innovation to the limit and have it realized through our intelligent workshop. Based on GNSS, Tersis products are empowered by its own technology with integrated wisdom of skilled professionals. Fully independent in R&D, Tersis's products provide assured, accurate position. Our latest RTK system, Oscar GNSS Receiver, provides accuracy less than 2 centimeters. Not only do we deliver high-precision products, we strive to deliver perfection. By 2021, Tersis products have been favored by users in more than 90 countries and are stepping up to reach more regions worldwide. A great news, Tersis GNSS wins the largest order in Nigeria with 185 Oscar GNSS receivers. Again, we are chosen by the experienced. In the era of intelligence, everything is connected. Tersis trusted GNSS solutions link the information and the globe. Unlimited value is created from extensive application in unmanned aerial vehicle, autonomous driving, surveying, machine control, precision agriculture, etc. Every millimeter counts. We always keep ourselves ready for the next breakthrough. Meanwhile, Tersis GNSS is determined to achieve growing business values for our partners and customers, which will be generated from devoted R&D, continuously strengthening technologies and expanding diversified applications. Unstoppable in exploring and surveying the globe, Tersis GNSS knows exactly what the world looks like and gets right to the point. Together, we drive life changes by creating infinite possibilities. Yeah. Welcome to Geospatial Night, where data meets precision and knowledge becomes power. With the GS, yeah. Welcome to Geospatial Night, where data meets precision and knowledge becomes power. With the GS King. The sky, yeah, we map it all. Satellites above, hit the system call, forward and it's locked. Every point precise from Lagos to the world. Yeah, we set rock, star, TK flow, centimeter dream. Force on the network, tighter than it seems. Leader in the air, scanning every plane. Turning point clouds into insight, getting aerial vision. We don't guess, we know. Photogrammetry make the model flow. From construction site to the curve, we define the future. This is how we live from beginning to set. Got a story to tell. From the earth to the orbit, we read it well. Elevation rising, no limit stuck. Get ready for the knowledge. Get spatial. DTM accuracy, got the message profound. UAV flight, yeah, we capturing truth from the pixels to the point. That's the power of proof. Surveillance, engineers, planners align, oil and gas, agriculture data redefined. Smart cities, watching with Geospatial Corp. Every industry knocking on the day. Growth pervades image depth to the skyline view. Every day, that clean, every output truth. DNS king, not the insight city, unlocking global deal. So mastery. See the world in coordinates. Every line tells a story. From the ground up, we elevate, turning knowledge into glory.
You're welcome to Geospatial Night. You're welcome to Geospatial Night, everyone. You're welcome. It is a pleasure to be hosting another night with every one of us. My name is Chika Okorocha, and it's a pleasure to be here. Let me just do a little introduction. First, I want to welcome Surveyor Peter Ogolo. It is wonderful to have you here. That's the Surveyor General of Rivers State. You're welcome, sir. I'm welcoming Harun Kolade. You're welcome. I'm welcoming Abduganu Shuaibu Abayomi. You're welcome. I'm welcoming Surveyor Digun Semiu. You're welcome. I'm welcoming Infinix X6887. You're welcome. I'm welcoming Xiaomi 2409. I'm welcoming Redmi A5. I welcome Dapul Asa. I'm welcoming Topsy. I'm welcoming iPhone. I'm welcoming Elijah Ola. I'm welcoming Idika Sonny. I'm welcoming Savio Emmanuel Jayoba. I'm welcoming Big Mo. Big Mo, you're welcome. Welcoming Mr. Innocent, William Anebo, you're welcome. Nuruddin Adegoke, you're welcome. Melvina Olisa, you're welcome. Savio Fumi Mavre, you're welcome. Abdurrahman Umar, you're welcome to this night. Opwene Bade Bari, you're welcome. Eminence Gold, I can see you. You're welcome. Kayode Olaifa, you're welcome to this night. Francis Otia, a frequent person, you're welcome. Nzube Chuku Okoro, I can see you. Marvin Charles, I can see you. Orji, I can see you. Sobio Folorun Shoshegun, I can see you. Chris, you're welcome. Lukman Oguneye, you're welcome, sir. Infinix X688, you are welcome. Osazi Aigbe, you're welcome. Sheye Adelegon, you're welcome, sir. Oyebanji, you're welcome. Osazi Aigbe, you're welcome. Lenovo, you are welcome. Muyiwa, I can see you. Roots Usman, you are welcome. And every other person I have not mentioned, please permit me I welcome you all. Akombi Abdul Hakim. You're welcome. Everyone, you're welcome to this night. And we having a new topic tonight. If you can hear me, just go to the comment section and type, I can hear you, sir. Just type, I can hear you. And I will just encourage us, since you have the Zoom link in your email, you can share the link, you can copy it and share with your friends that you think should be here with us. Ian Acho, you are welcome. Tijani, some people are still joining. You are welcome. 2 persons also join. You're welcome. Tijani, you're welcome. Ian Acho, you're welcome. Please go on and share the link. Okay, good. I can see a lot of, I can hear. Perfect, perfect. So this is another night. This is another night of sharing knowledge. And let me share my screen so we get into it. Please, can you see my screen? I just want to be sure. If you can see my screen, just let me know, please, in the comment section. Just drop a comment if you can see the screen. If you can see my slide. If you can see my slide, just drop a comment. Oh, I can. Redmi A5, I can. Yes, I can. Can you see my slide? Yes, I can see. Perfect. So that's the topic we'll be looking at today. That's our topic for today. Let me be sure everything is still intact. Okay, good. We have, as at this time, we have 52 persons live, and it's time for us to start. So this topic is something I'm passionate about. Someone is raising his hand. Okay, let me say maybe it's by mistake. So this topic is something I'm passionate about because the geospatial industry is changing, and because it's changing, there is need for us to begin to move with the industry. For us to move with the industry. And the next big thing, there was a period of time, it was total station. Everybody wants to have a total station. Excuse me. From total station, we went to the era of single frequency GPS receivers. From that era, we moved to a lot of people using RTK, core station. And at the point we got into the industry of drone mapping, a lot of people are going into drone imagery, drone mapping. And before you know it, it seems as if everybody is now getting used to drone. We are now even in another era of drone where we are focused more on LiDAR mapping. You have a drone, but do you have a LiDAR payload that can map deep forested area? We'll talk about that in some other geospatial nights. But From GNSS receiver, we now entered an era of GNSS Assisted Photogrammetry and the industry of building information modeling. That leads us to terrestrial laser scanning. It's no longer enough to just carry out an as-built survey. Some client might be interested to capture reality. We call it reality capture. What has been built? Can we have a digital replication of exactly what we have built? And that is where digital twin come into play. And the question now will be, how many surveyors, how many geospatial professionals, and now I choose to use the word geospatial professionals even beyond using just surveying, because we have surveyors that are geospatial professionals, we have engineers that are geospatial professionals, we have geomatic engineers, we have GIS analysts, photogrammetry guys, people that are even just in building technologies. We have people like that, builders. We have architects still in this geospatial industry. And the geospatial industry, like I prefer to say, is because the audience is anyone that is involved on the surface of the earth and has to do with location information. So an architect will build on a position on the earth surface. An engineer will do his own piling on a location, on a position on the earth surface. The surveyor will bring to life the entire engineering design, the entire architectural design, will bring it exactly where it should be on the earth surface at high level of precision and accuracy. So this industry covers every one of us. And if the next big thing I would say in some other part of the world, it's even everywhere in the world, digital twin laser scanning is big. If we have someone joining us, sometimes we have people from outside Nigeria joining us. If we have somebody outside Nigeria joining us, I'll just like you to just type, I'm here, and you have been involved in the industry of laser scanning. You can just drop a comment so that we know. I'll just pick your comments here. If we have people joining us outside tonight, you can just drop a comment. So this has become a serious industry. And we've had a couple of people reaching out to us, and even some surveyors and engineers that we've interacted with that are making us realize that this is big. And really, in the last 3-5 years, this industry has been held by a limited amount of people, I would say. And that is the interesting thing about industries like this. When it is new in a particular region, it is always interesting to know that it is few people that go into it easily. And that is what we want to talk about, comparative analysis. So recently we did a research where we've done a night where we've talked about GNSS Assisted Photogrammetry, where your receiver can capture point cloud. And with that point cloud, you can build a model. With that point cloud, you can build a model. Hold on. I just realized I've not clicked record. 1 minute, please. So like I'm saying, this is an industry that we all should begin to think about going into. And we carried out that research comparing total station observation over the building you can see on the screen, selected points. We use the terrestrial laser scanning to scan the building, and we also use a GNSS receiver that has a point cloud ability to scan that building also, to capture and build a model out of that building. And we're asking the question, can these two solutions compete in giving us a reliable accuracy to be in the business of building information modeling or laser scanning or point cloud generation over a building or facility? That is the question. And the topic is comparative accuracy assessment of point cloud in terrestrial laser scanning and GNSS assisted photogrammetry for scan to BIM applications using total station as our reference. So the digital twin life cycle. Now, the idea of digital twin is creating and managing the intelligent built environment through building information modeling. And in that regard, we are talking about the information about the structure of the building, structural integrity information. We want to understand every component of a building. That means there are some scanning operations that will require you going into the building to scan, while there are some that might just require you capturing the external components of the building. And this could be applied for mechanical engineering. They want to understand the piping. Maybe there is an oil refinery or a factory, and they need someone that can scan the entire facility out. So that is what we are looking at. So the core architecture of BIM, building information modeling, is understanding the 3D geometrical shape of the building or infrastructure, and integrated intelligence. Integrated intelligence can be what is the color of the building, what is the shape of the building, what are the dimensions of the building. That is critical. And from there, you can produce what we call a digital twin, where every facade panel of that building is redesigned and modeled out in point cloud using different approach. And that is what we are talking about. You produce a 3-dimensional geometry of a building from terrestrial laser scanning of that building. And from that, you can get intelligent information out of the building without necessarily going there physically. And that means from that point cloud, a digital twin can be generated. So building information modeling involves bringing out a digital replica of a building so that intelligent information, geometrical information about that building facility can be generated out. That's what we're talking about. And the anatomy of this integrated intelligence is geometry. You need to understand the geometry, and by geometry, we are talking about distance, bearing, height, dimensions, assets information. How many windows are there? You want to take inventory of the existing features of that building. That can be done with the digital replica, the digital twin. That can be done out of it. Maintenance data. You need this. Let's say you want to carry out routine maintenance. Your clients might require this information, and they can use the digital replica to define the amount of costs that might be needed. Engineering information can also be gotten. Materials, what kind of material were used? Because a scanning of the building can give us what we call, there's something now called Gaussian splatting, where you can carry out a splatting of images that is gotten from a terrestrial laser scanner, and your client can have a visual view of every facility in that building or in that facility. Maybe it's a factory, or what are the pipes, connected pipes. You can have that. And beyond the shape, we must understand these two things: the standard 3D model and intelligent digital twin. So the standard 3D model talks about surface level geometry representation. It lacks integrated non-graphical data and primarily used for initial design and visual approval. There could be a requirement for visual approval. They want to understand the level of beyond just pictures. They want to understand a geometrical understanding of the building. And that is just the surface level. But if we now go, so we see the primary function to show what a building looks like beyond just images. But they want to have some level of intelligence so a 3D model can come out of it beyond just image. Intelligent digital twin, this is the higher level where that embeds what? Multiple layer, transparent structure information, system data, embedded engineering information, material, quantities, and cost metric directly into the component. So you can pull out all these. That means digital twin takes on beyond just the surface. What kind of material has been used? And from that, we can to simulate how a building behaves, the cost, and how it operates. So a digital twin is having a digital environment of an existing infrastructure. So for a digital twin to be complete, there must be internal and external scanning, laser scanning of that building. So that clarifies that. So going on, if we look at this, the permanent digital set outliving any single project phase. So that's what we can call this. If a building is completed and we carry out a full scan, so this is beyond just as-built. An as-built survey, external as-built survey, can give us the external dimension. But a digital twin will give us a complete information of the building that covers, that can go on from planning, decommissioning if you need to demolish the building, renovation, design, construction, how the building operates, and maintenance, and maintain, how can it be maintained. So if we have this digital replica, let's say anything goes wrong in the building, the digital model can show exactly what it is. And this requires high level of scanning. And that is why there are various options in this business of building information modeling. There are various options. We're going to go into that. So the ultimate decision engine comes from a full optimized workflow of a building. The true value of building information modeling is by unifying cross-disciplinary data across every stage of physical existence. BIM equips stakeholders to navigate complex environments with total operational clarity. So imagine having a 7-story building. It's not every day you might need to go there every day to after it has been completed. A building information model completed up to a digital twin will give the stakeholder a full information about that building, and they can take critical decision. And now note that this industry is growing in Nigeria. And once an industry is growing, the first people that go into it become knowledge experts in it. And that's why we're sharing this knowledge freely, so that we begin to develop ourselves in it. And this is the foundation. Let's go on. Sorry. So the reliable digital twin require absolute spatial fidelity. So for us to have a very reliable digital twin, we need to understand a complete spatial fidelity. And spatial fidelity means a full geometrical understanding of that building. Now look at the image you are seeing there. You have a building existing and you scan it point cloud. After scanning, from that point cloud, a digital twin comes out of it. The one at the third image you're seeing there. So BIM evolution, building information modeling, has transformed the architectural construction engineering sector, EAC, architectural engineering construction sector, demanding highly accurate, intelligent 3D reconstruction known as scan to BIM. Scan to BIM. So this is now a new requirement. And the data foundation, the structural integrity of a digital twin, relies entirely on the precision of its underlying point cloud. You can see that's the middle. How accurate your digital model will be requires how strong your point cloud is. And that is why there are different requirements in projects that has to do with this. There are different requirements. And the requirement has to do with the level of details, LOD, the level of details required. And now the last one, operational friction. Why terrestrial laser scanning is the benchmark. It brings high costs, logistic complexity, and occlusion issue. Photogrammetry offers scalability, but accuracy depends heavily on lighting, texture, and control distribution. Now, everybody will just say the only way I can go into the business of digital twin creation, building information modeling, is me having a terrestrial laser scanner. That's what most people think. And that's why we're having this webinar. Let's go on. So, and the truth is, that is not the only area. There are different areas you can look at, because hitting the mark, accuracy threshold, and the research gap. Now, the reality is, it is the requirement of your project that can determine what you want to deploy. Now, in the business of building information modeling, there is something called level of detail. And there are 1, 2, 3, 4 options in that. We have the level of detail between the 100 and 200 mark, and that is looking at 50 millimeter level accuracy, and that's around 5 cm. And we have the higher one that can go into fabrication. So now the level of detail required for you to build an external feature of a building is different from the level of detail required if there is a fabrication requirement. If a factory needs a pipe that they need to fabricate, and they need you to go and scan what is existing so that they can build a replica of it, the accuracy requirement is different. And in the business of BIM, it is called level of detail. The level of detail requirement is different, and that is the tolerance level. So we have tolerance level from 50 millimeter to tolerance level at 5 millimeter. And now what you are going to use for a 50 millimeter tolerance level is different from what you're going to use when the tolerance level is 5 millimeter. So that is what we must understand. So despite existing research gap, there is a lack of structural control comparison. So most times in this industry, there is no real-time comparison of what is the level of detail that I can get. What kind of application can I even use a low-cost scanning tool to go into? And that is why you are here this night. Let's go on. So the big question I keep asking is, the reality of the modern BIM, construction industry demands digital twin and facility management. Construction industry, this industry requires scan to BIM workflow are becoming the standard. It is a growing demand. But the question I'm going to ask, there is a hardware bottleneck. High quality point cloud data is required, but terrestrial laser scanners remain locked behind prohibited cost accessibility constraint. And this brings me to the question. I would like us to just look at the group, come to your chat place and drop a comment. If you have a terrestrial laser scanner or you've used one, I would like you to just drop a comment in the chat box. If you've used one, say yes, I've used one. If you've not, say no, I have not. A terrestrial laser scanner. If you have used one before, say yes, I've used one. Great. Adigun Semu confirming, yes, I've used one. Olusegun Mayo, yes, I have. That means I've used one. So that's 2 persons saying yes. I'm having, no, I have not. I haven't used TLS. I only see it in video. Okay, great. No, I have not. Not yet. Kayode, not yet. Who else? Okay, no, I have. I have gotten just 2. Yes, I have used. Akombi, yes, I have. No, I have not. No, I have not. Yes, as a student. Okay, great. No, I have not. So it means we're having more no's and yes, meaning most of the people that have used this is either when they were in school or in very big organizations, they were able to have access to this. So it means there is a bottleneck. So if you can confirm with me that there is a bottleneck because of cost, I would like you to just drop a comment also and say cost is the issue. Cost is the issue in the comment section. Cost is the issue. Let me be sure we are all flowing. Cost is the issue. Why I've not been able to have access to this? So just cost is the issue. Okay, cost is the issue. Absolutely, yes. As a student, because it's so expensive. That's from Olusegun. Use it as a student. So Mayo used it as a student because it's so expensive, and that is the truth. It is very expensive, but this industry requires collaboration. The first thing I would say is knowledge. You cannot begin to go into this industry if you don't even have the basic knowledge. And this, just coming to this webinar alone, the over 50 of us live here, some have the knowledge, will gain some additional knowledge in this industry. And I tell you, the first time I carried out a drone mapping on a project I was involved in as Sacredion, I never had that drone. So sometimes you must not have this equipment before you can have this project and go into the project. The first level of going into this industry is I want to go into the industry. For me, that's the first level. The first time I went into the industry of drone mapping, I never had it. I never had the drone personally. I was able to rent a drone from someone to carry out that project. So that means it is not until you have the equipment before you can get involved into it. Cost is an issue, but one, there is collaboration, and now there is an easy access into this industry. And look at the question we are asking. Can GNSS Assisted Visual Positioning provide practical, cost-effective alternative without sacrificing scientific rigor? That is the question, because now in our last Geospatial night, we talked about an RTK capture receiver, where we now have GNSS receivers that have the ability to do visual photogrammetry, where images, just like drone, can be converted into point cloud. And if you model the building effectively, you can actually build the point cloud of that building and build a digital twin of that building. Remember when we talked about level of detail, people asking for this slide. Yes, I'm going to share the slide as long as you register for this webinar. This webinar is streaming on YouTube. You have it on YouTube. And I'm also going to share this slide to everyone that registered. Maybe that will be tomorrow. I will send an email with this slide. So don't worry about having this slide. I'm going to share this slide. So we talked about GNSS receiver that can carry out visual photogrammetry, where you move around the building. The last time we had this webinar, you scan the building, multiple images are captured, and from that images, you can build point cloud. Interesting thing about that, you can even use that same technology to carry out volume computation, what we call, it's still like a modeling, what do they call? Stockpile. Yeah, exactly. That's the word I was thinking of. Stockpile. Stockpile of sand, stockpile of earthwork. You can just use that receiver and move around it, because to carry out that, you can use a terrestrial laser scanner. You can use a drone to carry out that. So we're asking, can GNSS assisted visual positioning receivers provide a practical, cost-effective alternative for terrestrial laser scanning without sacrificing scientific rigor? This is the big question. This is the big question we are asking. And that is why we are here tonight, to provide an answer. So this was what we did. I'm welcoming the 60 of us. We're currently 60 live in this webinar. I'm welcoming everyone live. At the end of it, I will still see the number of people I can still call. So this is the big question we're asking. And we carried out a test. On the right-hand corner is a two-story building, an office complex, our office complex in Lagos, where we are having part of the floor. We're on the second floor in this building. And we carried out a scanning of this building. And what is the workflow? We use the total station to observe 16 points around this building. That's total station, and that became our reference data. We now use a terrestrial laser scanner. We own a terrestrial laser scanner to scan this building. Then we also used an Oscar Trek, which is a photogrammetry GNSS assisted receiver, to go around and also capture this building and build a model. And what did we do? We generated points cloud. We processed the points cloud from the terrestrial laser scanner, from the GNSS receiver. We also carried out accuracy assessments, root mean square error calculation, bias, and standard deviation analysis was carried out. Then we did a comparative analysis. And from that, we also did what we call data completeness check. Now, the idea of data completeness check is to know, how is this model actually performing? Is every component of this building modeled accurately? Are they modeled correctly? That is the data completeness check that we carried out. And that's what we are looking at today. So this is what we're doing. This is what we're saying. Hardware that were deployed. The first one, there is the total station. A reflectorless total station with 2mm level accuracy observed over 16 well-distributed points. Then we also use a real Aculas terrestrial laser scanner. Now, this scanner generates 500 points per second. 500 points per second. So moving around this building, 500 points per second, it captures the model. So this is like the standard, 500 points per second. You can use this for any level of detail. And this is under the category of 5mm level accuracy. So this scanner has an accuracy of 3mm level, 3mm accuracy, meaning no matter what you are interested in, this scanner can scan it and provide you with highly precise digital model of that facility you are scanning. Then the next one, and we call that an active scanner, because it generates 500 points per second, and the points cloud comes out immediately. So that is an active scanner. But a GNSS assisted photogrammetry, meaning a receiver that has cameras around it, and IMU technology. What does it do? An RTK receiver receiving satellite signal, receiving correction from a base station or a core station, and has IMU capability, meaning you can just take a walk, not necessarily holding your pole straight. And the inertial measurement unit can carry out the correction on the movement. Then you also have a camera that gives you images. And with that, that's what we call measure what you see, a direct georeferencing of your images using entry core station or a regular base station. So that is a passive receiver. Why is it called passive? It is called passive because the point cloud are not coming out immediately. you need to capture those series of overlapping images. Then you process those images to generate the point cloud. So that's the difference. So an active scanner generates the point cloud immediately. You export the point cloud. When you go to the point cloud processing software, all you need to do is just to carry out corrections on your point cloud, and your point cloud is there. But for the passive GNSS receiver, it captures overlapping images, and you process those images to generate the point cloud. So that's the difference. So what happens? And that is the site on the left, the 3-story building. 16 points well distributed around the building were observed with a total stations in X, Y, Z. So that is our approach. So what happened? What you're seeing on the left-hand side, it is not an image. This is a model. This is point cloud model. So we just did a screenshot from the software environment. So this is point cloud generated from Terrestrial Laser Scanner. So this is Terrestrial Laser Scanning architecture. The one on the left, this is also a point cloud. Looking at it, it looks as if they're exactly the same. This is also a point cloud generated from a GNSS photo architecture. So now, high density active structural representation via Road Aquilas Terrestrial Laser Scanner. Why this other one is a passive structural reconstruction via Tassos Oscar Trek, generated through structure from motion using direct GNSS georeferencing. So that's what we're talking about. So the technology behind it is structure from motion. That is also the idea behind photogrammetry using area mapping. When you map an area using a drone, the structure comes out from moving objects. So the guy holding the GNSS receiver is moving, capturing images, but while processing in the software, it pulls out the structure from the images. So this is structure from motion, and that is what we are seeing. So looking at them, it seems as if they are the same, but within the software environment, they are not exactly the same. And so let's go on. So when we use the Terrestrial Laser Scanner, we were able to capture all the 16 points. And those 16 points were placed with, there was a place marker we placed on the wall around the building. So completeness, 16 out of 16 control points, perfectly recovered. Results, we had a dense, comprehensive geometrical detail representing the building, which became the ultimate baseline. But what happened when we used the Trek? When we used the Trek, we could not see all the points. We're only able to see 6 of the points, meaning Trek has some limitation. We'll talk about that. So why the Terrestrial Laser Scanner pulled out all the place marker we placed around the building, clearly we're able to extract all of them, 16 of them. But for the Oscar Trek, we're able to speak 6. We're able to speak just 6 out of 16. But the question we're going to ask, let me go back. So the question we're going to ask is, does this mean there is a total failure? No, we're going to come to that, and we'll explain that. So what we did to analyze that result is we carried out an analysis using root mean square error. We carried out analysis also using bias analysis. Then we also carried out standard deviation analysis over the data. Now, since we had 6 points that were fully captured, we decided to analyze those 6 points in relation to the 6 points of the Terrestrial Laser Scanning. I hope you understand that. So just hope there will be time for question, but let me come back to that. Using the GNSS receiver, were able to recover 6 of our place marker around the world. The other ones, we could not see them clearly. Meaning, when the detail is highly precise, that's why when your interest is 5 millimeter, you might not be able to see some. But the terrestrial laser scanning can see every detail required. So we decided to take the 6 points that we saw, the 6 marker that we picked out, and also the same 6 marker of the terrestrial laser scanning. I hope you understand that. So let's go on. And we carried out root mean square error, and root mean square will measure positional accuracy to measure the overall magnitude of deviation between the generated point cloud and the ground truths. Remember, what we are comparing is the point cloud with respect to the total station observation. So we carried out root mean square error. We carried out a bias error. And what does the bias do? It reveals if a data consistently drifts in specific direction. So is there an overestimation of the reality of the building, or an underestimation? That is what bias does. And a standard deviation will carry out internal consistency. Are there consistency between the point cloud and the total station observation? So these are 3 levels of analysis that were carried out. Now, and 3 levels of analysis that were carried out. What became the results? And that's what you're seeing here. So the scorecard, positional accuracy, and the total station. So when we carried out the analysis of those 6 points, we realized that the terrestrial laser scanning, we got 1.2 cm. This 1.2 cm. We're able to get 1.2 cm in X. Why the GNSS Assisted Photogrammetry were able to see 1.3 cm in the X, in the eastern direction. Look at the tie. So that is a close tie. When on the y-axis, the northern axis, the terrestrial laser scanning gave us 3.2 cm in comparison to the total station. So this is the deviation we got, the root mean square error in the northern, 3.2 cm. We're comparing with the total station observation. Why for the GNSS photogrammetry system, we got 1.4 cm. Now look at this. It means the photo wins, right? In that regard, just note, this is just for 6 points. For the terrestrial laser scanning, we got 7 cm, the overall in the height. Why for the photogrammetry, we're able to get 4 cm. But if you compare these readings, you realize that they are all close. That means if someone has a GNSS receiver and is able to handle the observation of a building information model, not just any GNSS receiver, you can clearly see that it is a good entry into the business of digital twin creation. A GNSS receiver that has a camera, not just any camera, but a receiver that has the ability to carry out this function we are talking about. Because there are some receivers that don't have this ability. All they do is just for visual stakeout, but not visual photogrammetry operation. Not visual photogrammetry. So if you have a GNSS receiver that can carry out visual photogrammetry, meaning from the observation you carry out capturing images, those images are geometrically correct and they can be processed into point cloud using the software of the GNSS receiver. It means this research is letting you know that you can go into this industry easily. Because for you to have this receiver with as low as 4 million, about 4 million naira, you can have this receiver with this function. Now compare it with the terrestrial laser scanner that is 45 million naira. Just compare it. You can see, so we are saying this is an easy access for every one of us. at least you can operate at the first level of about 4 cm required, which we call the level of detail. A level of detail of 50 millimeter, which we broke down as the first level. You can operate in that level with just having a GNSS assisted photogrammetry. And that is why we did this research. And that is what we are saying. So TLS, terrestrial laser scanning, shows minimal horizontal systematic error, but slight underestimation in elevation. Photogrammetry actually exhibits tighter standard deviation. But note, the difference between these two is the GNSS assisted operation, you need to be close to the building. You need to be within less than 20 cm from what you want to scan. Whereas the terrestrial, you can even be above 100 meter, even 300 meter away, and it can still pull out this model. So you can see the plus, the con, and the pro and the con. Let's go on. So before I go on, please, I just want to be sure we are all together. If you are following me to this point, just type in the comment section, I am following. Let me just be sure everybody can still hear me. I'm looking at the comment section. I am following. Just type following. Perfect, perfect, perfect. I'm following. So great. So that's what we are talking about. So you can see, so this opportunity is not limited to only you having a terrestrial laser scanning. We have tested it and we have these results. And the paper is available. I'll share the paper. Like I said, I will share both the research paper and I'm also going to share this slide so that you can go through it in your spare time and also ask questions. You can send me email and you can also chat in our Telegram channel. Remember, we have a Telegram channel. If you register, there's a Telegram channel where you can also join us, and questions, we can take questions and answer. But for the slide, I'm not going to share the slide in the Telegram group. You can only ask your question. I'm going to share the slide and the paper to the emails that register for this webinar. So for you to be here, that means you register. We are currently 66 of us live. For you to be here, it means you register for this webinar. So that's what we are saying. Did visual photogrammetry fail? No. So you can see, visual photogrammetry did not really fail. But remember, I said in the building information modeling, there is something called level of detail. Maybe this might be the first time you're hearing that. There is something called level of details. And when a project is given, the project comes with level of detail specification. And level of details falls between category 1, which is about 50 millimeter, that is 5 cm, and the highest category, which is 5 millimeter for things like fabrication industry. So that is the level of detail. So depending on the level of detail, if it's just external building modeling, your GNSS assisted photogrammetry can carry out that function. So who says you can't go into this industry? Who says you can't begin to talk confidently that this industry, that not only am I going to deliver to my clients as-built survey, I can also deliver to my clients a model of that building, whereby I can pull out the .las file to the clients from a GNSS assisted photogrammetry tool. So it did not fail. The hardware is accuracy. The metric here is accuracy. What level of detail is required? Status, we've proven that it is possible. Insights, the RTK GNSS and IMU integration perfectly captures coordinate data when features are clearly identified. Can you see that? When the features are clearly identified, the accuracy is competitive. That's what we're saying. So it means how you capture the data, because what we did here was not to take serious precaution in the data capture. Just carry out an easy walk around the building, capture it, generate the point cloud, and let's compare it. So the workflow here is completeness. How complete is the model? And the status is it can be optimized. Optimization. Missing points are not a fatal hardware flaw. They are a direct result of acquisition strategy. So that's the point we are making. The missing point is not because it is an instrument blunder, but it is the acquisition strategy. Meaning, if we could take our time in moving around, multiple capturing of that building, we can clearly capture those points that we're missing. So it means the result is a result of the acquisition strategy. If I can carry out an overlap and carry out multiple line of sight data acquisition, I can model that building more precisely than the level I'm in now. Let's go on. So what becomes the solution? How to optimize the passive sensing workflow? That is critical. So if I can go, at least I can begin with a GNSS Assisted Photogrammetry tool. How can I improve the capturing strategy? How can I improve it? That's what we're talking about. Number one, 70% image overlap between consecutive observation. It means, one, I carry out more observation because it is building the model from the point cloud. So if I can carry out more observations, I would be able to build the model. So this image I showed here is like I have a building, I move around multiple places, angles, having multiple viewing angles for robust feature reconstruction. So I capture the building from multiple angles so that I can accurately build the model. That's what we're talking about here. Another thing is what? Close range. I need to stay a bit closer to the building. Remember, I don't need to keep my pole straight because the receiver has IMU integration, initial measurement unit integration, meaning even if I tilt my pole, I can still capture images that can process. Once my GNSS receiver is communicating with the core station or communicating with the base station. Another thing is carry out this observation when the environment is bright, well textured, sufficient light in the environment I want to scan. So if I can integrate this data acquisition strategy, the model, the reconstruction of the model will be optimized, can be optimized. That is what we are saying. It can be optimized. So let's go on. So when workflow is optimized, completeness drastically improves. That is what we are saying. So we are saying not every project requires a terrestrial laser scanner. That's what we are saying. Remember, I talked about the level of detail, and the lowest level of detail and up to the highest level of detail. The highest level of detail is the level of detail between 400 and 500. And 400 and 500, we're talking about 4 millimeter to 5 millimeter accuracy. So for that level of detail, it is for things that involve industrial refineries. So if you are going to model an industrial refinery, you are not going to use a GNSS Assisted Photogrammetry receiver. You are going to use a terrestrial laser scanner because at that level, we are talking about level of detail at 4 millimeter to 5 millimeter. Complex heritage preservation, fabrication. So that is what you can do. But if you are talking about external building modeling, you can use a GNSS Assisted photogrammetry. Property documentation, you can do that. Facility management, they just want to see how many buildings are there. They want you to model it so that they can do the dimensions out of it. Remember, we are having about 1.3 centimeter accuracy, so you can easily do dimensions, measurements dimensions with that. You can measure a door, you can measure things like that. And you can showcase things like that. Progress monitoring. What is the progress of work done? What is going on? So visual positioning photogrammetry. This is the territory for that. So that is possible. So you can look at the graph we drew here. Project complexity, fidelity needs. When it is low, you can use a visual positioning device. But when it is high, you can use the terrestrial laser scanning. So like I said, understanding the level of detail is very critical and very important. Let's go on. So at this point, I want to play a video to discuss what I'm talking about. I'm going to play a video for us now so we can see an area where this can be applied. I'm going to play a video for us.
This is a typical earthwork site. Traditionally, you survey boundary points, then click dense points measurements, and finally build a mesh to calculate volume, often requiring hundreds of points. Now, all reduced to just a short video. Simply walk around the pile and make sure the entire area is captured. Finally, build a mesh to calculate. This is a typical earthwork site. Traditionally, you survey boundary points, then click dense points measurements.
Please, can you see my screen before I play this video? Can you see my screen? Let me be sure we can see it. Can you see my screen? Just say yes, I can see. Let me be very sure we can see the screen. Can you see the screen? Volume measurements. Volume measurements. Yes, I can see volume measurements. Okay, great. Let me play the video now. So this is a GNSS Assisted Photogrammetry tool for computing volume of earthwork without the stress of going to use a total station and measure the point or expensive drone receiver. Now let's play the video.
This is a typical earthwork site. Traditionally, you survey boundary points, then click dense points measurements, and finally build a mesh to calculate volume, often requiring hundreds of points. Now, all reduced to just a short video. Simply walk around the pile and make sure the entire area is captured. Generate a full point cloud instantly right on site. Especially for terrain-like sand piles with rich texture, Capture RTK delivers more complete and detailed point clouds with 3 cm high precision.
So this is a video.
Based on point cloud,
and this is the model.
And fill volumes in seconds.
This is the point cloud model.
Results, instant visualization, higher efficiency. From raw terrain to volume, done on site. Capture RTK. Capture once, deliver more. Instant visualization, higher efficiency. From raw terrain to volume, done on site.
So what you're seeing here, this image, this is not a video, this is a point cloud. This is a point cloud of the earthwork, of the stockpile that was generated from the GNSS Assisted Photogrammetry tool. Normally, if you're going to use the terrestrial laser scanning here, it's like very expensive for you to scan this, or you fly a drone, but you just hold the GNSS receiver, walk around the building, it captures the images directly from your data logger. You click a button, it converts all those images into a point cloud, and that point cloud comes out like this. And that can even be exported, whereby you can also view in your computer. So imagine how fast it will be if you have various volume of earthwork and you are required to compute you have various stockpile of sand, and you have your client that is constantly doing dredging sand, and they need to compute the volume immediately. You just hold your receiver, walk around it, it builds the model. So this is what we are saying. So this is still modeling. This is still modeling. So this is stockpile modeling, and this can be achieved with this. And the same way, like I said, you can also do this also for inspection. And so let me stop this and go back to my slide. Is this interesting? If this is interesting, please just say this is interesting. If what you're learning tonight is interesting, I would just like you to drop a comment, interesting. Oh, great. So at the, back to our slide, Let me go back to our slide and we can continue where we stop. So great. Can you see my slide back? So please, I would like us to mute ourselves. Okay, I'm muting everybody already. So great, we are back. Can you please confirm you can see you are back to our slide, optimizing the passive sensing workflow. This just gives me the assurance to know that everybody is seeing it. Optimizing the, okay, great. You can see we are back. Okay, great. Thank you for that. Thank you for following. So this is it. So this is what we are saying. Let's go on. And we now understand that there are different projects. Depending on the project, that is what requires you to either use a terrestrial laser scanner or a GNSS assisted photogrammetry device that works with still the principle of photogrammetry, combining multiple images and converting them to point cloud. And somebody might want to ask, what is even the cost of this receiver? Let me just take a cost of this receiver and let you know that currently we are running a promotion on our Tassos receiver, and my phone number is there. You can just drop a WhatsApp message and I'll respond to you later in the night or tomorrow. So that's my WhatsApp number. If you're interested in our GNSS AGM promotion, we had this AGM promotion. We started on the 20th of June, where most of our receivers have dropped in price, and you can see the price. You can get just a single receiver. These are the regular receivers for 2.5 million or 3.5 million. You can get that. But if you're interested in the GNSS Assisted Photogrammetry device, that is the cost of it. Now, just compare 45 million for a terrestrial laser scanning and a 5.2 million only to be in the industry of building information modeling. And this is 5.2 as against the 6.5 million to be in this industry. That is my WhatsApp number. Again, you can chat me. And this is the higher option of the photogrammetry of the photogrammetry receiver. We call this one the Tassos TS30. The Tassos TS30 has dual camera for visual photogrammetry, and it also have a laser sensor that can measure over 60 meters in case you need to measure positions away from you. Over 60 meters, you can do that because the visual photogrammetry works within 15 meters away from the building. While the laser, you can measure over 60 meters away. This does that. And the other option is the Tassos Oscar Trek. The Tassos Oscar Trek is what we use for this research work. That is going for just 4 million naira only. And 4 million naira against 5.5 million, and you are going into the business of photogrammetry. We also have a scanner. This is a hand slam scanner. This is a cost-effective scanner that is cheaper than the terrestrial laser scanning, but can still do the work. This one can generate 200,000 points per second, while the terrestrial laser scanning can generate 500,000 points per second. This is very cost effective. This is just 8.5, it's usually 12.5 million, but on the TASOS promotion, it is 8.5 million naira. And this can give you higher level of detail, LOD, that we're talking about, higher level of detail compared to the GNSS Assisted Photogrammetry. This gives you a much more higher level of detail, but still below a full terrestrial laser scanning. But this is also very good. And again, that's my phone number, 070 48 66 87. Remember, you can chat with me on any of these options. And I'm also going to share this slide with you. And with this, remember, take the number 070 30 48 66 87. You can talk about the TS30, any of these, our standard GNSS receiver on the promotion price, the TS30 visual photogrammetry, giving you the first LOD level of detail, or the Oscar Trek, or the hand slam. You can chat me on any of them and I'll do well. Let's go back and let's continue with our slide. So we are saying there is a bigger opportunity for everyone. The GNSS assisted tool has democratized reality capture. It is no longer only for terrestrial laser scanning. So why the highest level of integrity, the highest level of detail, which is around 5 millimeter, require absolute high fidelity, specialists in laser scanning teams, tackling rare, highly funded, complex infrastructure, highly expensive. Remember, we have this terrestrial laser scanning. Nobody should reach out to you and you are telling them, no, I cannot do this. No, we can collaborate. We have the terrestrial laser scanner. And for you, why? For everyday surveyor, utilizing existing reality capture GNSS receiver to capture 3D digital visual positioning twin for the broader real estate and facility management industry. So what are we saying? Look at this image I shared here. The sky blue represents the industry covering complex infrastructure mapping, while the green area represents the larger scope of the industry, meaning there is a larger opportunity for every one of us beyond even the tighter region. Look at that peak. Look at the pyramid. The pyramid. You can see that pyramid. Meaning at the epic point, there are fewer people. And still, I'm telling you, you can still be part of that fewer people because we have this terrestrial laser scanning and we can collaborate on the projects you have. Why on the lower part, which is most people can go into, but how many people know? But tonight that you join us on this session, you now know that you can go into this industry. By lowering the barrier to entry, GNSS assisted technology opens up massive new revenue streams for surveying firms. So we are saying there is a larger opportunity for every one of us to participate in this industry. That is what we are saying. And in this industry, the future, I would say, is hybrid. Terrestrial laser scanning on match point density, structural completeness, indoor capability. So you know the GNSS visual positioning only works outdoor. Why the hand slam and the full terrestrial laser scanning can work indoor. You can see that. But the future, I would say, is hybrid. Hybrid scan to BIM workflow, combining high-density laser point cloud with the rapid georeferencing photorealism of visual positioning to create the ultimate digital twin. So I would say the ultimate digital twin will come from a combination of GNSS visual positioning tool and terrestrial laser scanning. When we combine these two together, we are going to have the optimal, the ultimate digital twin for us to operate in this industry. And this will be my final point for every one of us. From coordinates to digital twin. This research and what we've done does not suggest visual positioning will replace terrestrial laser scanning. It proves that high quality reality capture is no longer exclusive to laser scanners. The future belongs to geospatial professionals who understand how to combine accuracy, accessibility, and fit for purpose workflow to deliver real business value. So we are saying it is not all about terrestrial laser scanning. It is fit for purpose workflow. What is the level of detail required for this project? And how can I deliver the right tool to get the results? And I want to say thank you for your time. And that brings me to the end of my presentation. It's now for me to take your question. If this session has been insightful, I would just like you to give me a clap in the comment section. Let me see the claps in the comment section. If this session has been insightful, let me see the claps in the comment section, the claps emoji in the comment section. Thank you, Okoro. Thank you, Okoro. Thank you, Mayo. Thank you for that. Thank you, Kayode. Thank you very much. Thank you, Oji. Thank you, everyone. Thank you. That means we've been joining us. We've been following. Thank you, everyone. I really appreciate everyone. It takes a lot to keep showing up and doing this, and you showing and joining. And when at the peak point, we have over 60 of us, and now we have over 50 still live. It means we are getting value for these live sessions. And it's time for us to go into question. So now you can drop your question in the comment section, and I will do well to answer them. You can drop your question in the comment section. You can drop your question in the comment section. If you have any question, you can drop in the comment section. You can drop your question in the comment section. Or if you want to speak, I can still give you the opportunity to speak if you want to speak also. We can still create an opportunity for you to speak. Any question for us tonight? Yeah, so Joe King is asking, can I still use the TS30 with a base? Absolutely. You can use the TS30 with a base station or with a core station. Let's take, for instance, you want to acquire the TS30. You can choose to buy the TS30 alone as a receiver where you want to work with the core station. Or you can decide to buy the TS30 with a base station, with a base. If you're getting the TS30, the base of the TS30 alone, the base alone is 4 million naira, is 4 million. And how do we get that 4 million? If you look at this, the base of the TS30 is just an Oscar Ultimate base. The promotion price of the Oscar base and rover is 7.5 million. The rover is 3.5 million and the base is 4 million. So that's just it. So if you're getting the TS30 alone is 5.2 million. But if you want the base along with it, it's 4 million plus 5.2 million. But if you are getting the Oscar Trek, which also does the same thing, but it doesn't have a laser, you can get this for 4 million and you can also get the base of it for 4 million Our promotion is still ongoing till the 31st of July. 31st of July. The promotion runs to the 31st of July. Please let me want to take more questions. Any other question? How can your GNSS rover give level or height? So that's just the standard thing. Now, the way GNSS operates is there are two heights. Ellipsoidal height is the standard height of a GNSS receiver. But how do you get the height? So if you work with the GNSS receiver, it gives you ellipsoidal height because it is being modeled with reference to the ellipsoid. But the height we need in our survey operation, that is just a mathematical surface. What we need in reality is the autometric height, or the mean, a height reference to the mean sea level. And that is why we introduced the EGM joint. And the latest EGM joint we integrate in every GNSS receiver you get from us is the EGM 2008, already integrated in the data logger. So when you observe with your GNSS receiver, you are not just getting ellipsoidal heights. You are also having the EGM joint converting your ellipsoidal height to the autometric height, which is like a height reference to the joint. So that is what happens with your receiver. I know, Vincent, you just got a receiver from us. That receiver you got already has the EGM 2008 global joint model integrated in it, and it can convert every observation you're getting with reference to the geoidal model, giving you a realistic height that relates to the topography of the earth you are working with. So that's a good question. Any other question on terrestrial laser scanning and visual photogrammetry? Any other question? I'm looking at the comment section. Oh, great. Does it mean that TS30 alone cannot capture interior spaces data? Very, very good question. Olusegun Mayo, that is a very good question. Another question, question number 2. Can the TS30 still do the normal XYZ for normal GNSS receiver? Amazing question. So that's a good question. That's a very, very good question. And the TS30 or the Oscar Trek, remember, it is a GNSS assisted photogrammetry tool for point cloud modeling. So that means it works with the satellites. So it cannot go indoor. When you go indoor, the satellite is gone. What can go indoor is the hand slam. The hand slam you're seeing, that the Tassos S1 hand slam 3D laser scanner. This scanner can work both outdoor and indoor. You can work with this scanner indoor, or the terrestrial laser scanner. The terrestrial laser scanner can work indoor and outdoor. So that's the pro and the con. So that's why we said this is good for observation that has to do with external data capture, external modeling, earthwork, volume computation of earthwork. So it can't go indoor, because if you go inside, it loses satellite signal. So that's the limitation. Then the second question, yes, you can use it for your regular XYZ observation. The visual photogrammetry feature is an additional feature that is available in Oscar Trek and TS30. So that is available in Oscar Trek and TS30. So TS30, that's where you are seeing point cloud visual positioning. That is an extra feature. So it does your regular XYZ, and you can carry it out for point cloud. So also the Oscar Trek does your regular XYZ, and you can use it for point cloud visual positioning. So that's a good question, Mayowa. That's a very good one. Any other question? Any other question? I'm in the comment section looking around. Any other question? Is there any other question from any other person? How long does data processing takes on average? So data processing, it's almost instant. One, you can process that data even from the field within the data logger. The second option is to bring it onto your software and you pull out your point cloud. So in less than 30 minutes, your point cloud is out. The point cloud can come out on the field. It's instantly. You can just select some images and the point cloud comes out. So in less than 30 minutes, your point cloud is out. While for things like stockpile, within 10 minutes, you've computed the volume of your stockpile directly on the field. Once you walk around the stockpile, once the model is out, you just click the point cloud. Within your data logger, the point cloud comes out. So in I would say less than 5 minutes, it's almost instant. The point cloud comes out. So that's how fast you can work with this tool. Any other question? I'm in the comment section. Any other question before we call it a night? So now for building to be represented in line. So that is where Olusegun, you are a surveyor and an architect. That is where you come in, because it gives you the point cloud. You can now take the point cloud and convert it to 2D drawings. So you get the point cloud, not just images. Point cloud, and that point cloud, you can export the point cloud to .rcp format, and that RCP format can be imported into software like Revit, where you can now pull out all the dimensions. Exactly, Revit, exactly. So you can bring in the software in a .rcp format, you bring it into Revit, and within Revit, you can pull out all your 2D dimensions as required, or even the full digital twin 3D model from the point cloud. So that's actually how the workflow works. Do we have any more questions for us? Any more question? And once again, I said I'm going to share this slide to every one of us. You have this slide in your email. I'll send out the email to everybody that registered. I know some people registered, but they could not join us live. I'm going to share this slide to everybody that registered. So I'm going to share this slide to everyone that registered. Like I said, you can chat with me. I can see some people already chatting with me. You can chat with me after the webinar. I'm going to respond to all the chats. I'm going to respond to all the chats that are coming after the live, after this webinar. So I'm still looking at the question section if I have more questions. Sorry, I came late. I did not get the class at all, but it's very interesting. Thank you, Vincent. Perfect webinar. Thank you. Thank you, everyone, for joining. It's been amazing having every one of us live. It's been amazing. It's been amazing. Let me see. So the Looker has zero impact on BIM. Yes. Tassos Looker does not has the visual photogrammetry. So this is a question someone is asking. So Looker has zero impact on BIM. Yes. So Looker does not have, what you see here on the screen is the Tassos Looker GNSS receiver and the Oscar GNSS receiver. These ones are just the standard receiver with tilt compensation for picking your points. So it doesn't have the camera visual photogrammetry advantage. The visual photogrammetry advantage is only available for these, the Tassos TS30 and the Oscar Trek. So those are the two GNSS receiver that has the visual photogrammetry advantage for BIM. So those two are the ones that has the advantage for BIM. Like I said, you have a larger, greener area that we can all operate in, a broader real estate and facility management market that we can all begin to operate in. And this is the opportunity we are sharing tonight. I'm still on this question section. I've been following you from Bauchi. Yeah, your name is not showing as Zaomi. I can't see the name. I guess you did not put your name while joining the live. You can just drop your name in the comment section so at least I can recognize you with your name. You can drop your name in the comment section. Zaomi. Oh, okay. So your title's Joseph Gambo. Thank you for joining us from Bauchi. Thank you for joining us from Bauchi. It's a pleasure having you. I'm happy to see someone joining us from Bauchi. Surveyor Chigere Padek. Thank you so much, sir, for joining us. Padek is one of our earliest users of TASOS GNSS in Nigeria. That was in 2019. That we just started barely less than 2 years, and he got a TASOS Oscar advance from us then. Thank you so much. Surveyor Ojo. Okay, that's the red meat. Surveyor Ojo Paul. Interesting. Thank you, Surveyor Ojo. Let me look at those that are still live and recognize and appreciate us for staying this far till this time. I don't take your time for granted. I'm really grateful for having all of us join. Surveyor Ismail Yakubu from Kaduna, thank you for joining us. Jubril Ajetumobi from Lagos, thank you for joining us. Keldo Lifa from, I think, Oyo State, thank you for joining us. Melvina Olisa. Melvina, are you in Lagos? You're in Lagos, right? Or Anambra? Thank you for joining us. Melvina Muritala Hakim, thank you for staying to the end. Nwaro, thank you for staying to the end. Unzu Bechuku Okoro, thank you for staying to the end. Okebola Samson, it's a pleasure having you from the beginning to this time. Oluwadara Emmanuel, thank you for being with us. Omar Yosef, thank you for joining us. Opwene Badepari, thank you for staying to the end. Oji, thank you for staying to the end. Osazi Aibe, thank you for staying to the end. Remember, my phone number is there. You can chat me any of the products you're interested in. Maybe the TASOS Luca, the regular one, the TASOS Oscar, or the visual photogrammetry receivers. You can chat me. I'm going to respond to your chat after the webinar. My number is there. You can chat me, 07030486687. Oyebanji, thank you for staying to the end. Osondu Christian, thank you for staying to the end. My big uncle, Surveyor Peter Ogolo, thank you for staying to the end. Redmi AZ, I wish you can tell me what's your name, Redmi, so that I can actually appreciate you with your name. Samsung SM, thank you for staying to the end. Samuel, thank you for staying to the end. Samuel Adimadu, thank you for staying to the end. Sheye Adelegon, thank you for staying to the end. Surveyor BU Farouk, thank you for staying to the end. Surveyor Shigere FNIS, thank you for staying to the end. Surveyor Folorum Shaw Shegun, amazing having you to the end. Techno KM7, great having you. Top C, thank you, great having you here. Top C, William Anebo, great having you here. Xiaomi 240, thank you, great having you here. Also Xiaomi 2507, great having every one of us. Let me look at the question section if we have more questions. Okay, is it possible to swap Luca with the advanced of visual photogrammetry? I would like you, I can't even see the name of this person. I'm just saying Xiaomi 2507. Xiaomi 2507, you can chat with me on this and we can have a discussion on that possibility. Somebody's asking, Bade Barry Aluao, are you an Agbai man? I don't understand that. I guess that's for somebody else. Good Surveyor, good to Pius. I did not skip you. Thank you for joining and staying to the end. Eminence Gold. Thank you for joining and staying till the end. Thank you everyone for joining and staying to the end. I'll still be looking at the comment section. Remember my phone number 070-3048-6687. You can chat with me on any of the options. We can look at the possibility, what is possible. We can look at all that, what is possible. You can chat with me on that and we can say what is possible. And let me just do a screenshot. I love to do a screenshot of the comment of the attendance so that I can just drop it on my WhatsApp status. So once again, let me play this video again for us to see.
It's a typical earthwork site. Traditionally, you survey boundary points, then click dense points measurements, and finally build a mesh to calculate volume. This is a typical earthwork site. Traditionally, you survey boundary points, then click dense points measurements, and finally build a mesh to calculate volume, often requiring hundreds of points. Now, all reduced to just a short video. Simply walk around the pile and make sure the entire area is captured. Generate a full point cloud instantly right on site. Especially for terrain-like set piles with rich texture, Capture RTK delivers more complete and detailed point clouds with 3 cm high precision. Based on point cloud, calculate cut and fill volumes in seconds. Accurate results, instant visualization, higher efficiency. From raw terrain to volume, done on site. Capture RTK. Capture once, deliver more. This is a typical earthwork site. Traditionally, you survey boundary points, then click.
So this is another video. This video basically shows the operation of the Oscar Trek or the TS30 in operation. I mean TS30. So when this is just how it works. You just walk around the building. Once you walk around the building, you just walk around the building. As you walk around the building, it captures everything, visual positioning. So this transforms into point cloud. Just watch as it changes. So any image you can click and it generates the coordinates. So that's the advantage of visual photogrammetry. Any point you click on the image, the coordinate comes out. So instead of you going to the exact point to pick, you just click anywhere the coordinate comes out. So that's another advantage of it. So that's the point cloud. So you can see exporting immediately. So that's the point cloud. Visualizing it on the computer. So you can see this model. So this was generated from a GNSS receiver. That's what we're talking about. So if you take your time and you capture more images, the model becomes clearer. And this is not a terrestrial laser scanner. So this was what we did that we used to carry out the check that you have there. The only limitation is you need to be close to the building. You need to be close. You don't need to stay far away from it. So with this, we come to the end of Geospatial Night with the GNSS King for the 4th of July. I look forward to having you for another interesting session.
Yeah.
While I play the theme song. So good night, everyone. And it's been a wonderful night having you for the Geospatial Night. And I look forward to another interesting session with you. Thank you very much.
Good night, Surveyor Chica.
Yeah, thank you so much, Chuka. God bless you. Good night.
Thank you, sir. Thank you, sir. Thank you, sir. Thank you so much, everyone. Thank you, everyone.
Thank you.
Thank
Have a
you.
good night. Yeah.
Yeah, have a good
Thank
night.
you. Have a good night, Chica.
Thank you, sir.
Good night.
Have a good night.
Scenes, leader in the air, scanning every plane, turning point clouds into insight, getting aerial vision. We don't get, we know. Photogrammetry make the model flow. From construction sites to the curve, we grit. We define the future. This is how we live here from beginning to set. Got a story to tell. From the first to the orbit, we read it well. Elevation rising, no limit in sight. Get ready for the kind of get spatial. Yeah, we model the ground. DTM accuracy, got the metrics profound. UAV flights, yeah, we capturing truth from the pixels to the points. That's the power of proof. Surveillance, engineers, planners align. Oil and gas, typical to data redefined. Smart cities, nothing with geospatial core. Every industry knocking on the data. Truth from Bay, dimmer to yacht to the skyline view. Every day, that clean, every for truth. DNS king, nothing inside kitty, unlocking global geospatial mastery. Either way.